हेलो एवरीवन, ज्ञान विजर्ड में आप सभी लोगों का वेलकम है। मैं हूं अजमल। इस वीडियो में एडियाबैटिक प्रोसेस के बारे में लर्न करेंगे। एडिया मीन्स होती है हीट। तो एडियाबैटिक प्रोसेस वो प्रोसेस है जिसमें हीट कांस्टेंट रहती है, या ये कह सकते हैं कि चेंज ऑफ हीट इज जीरो। देयर इज नो चेंज और देयर इज नो एक्सचेंज ऑफ द हीट बिटवीन द सिस्टम एंड सराउंडिंग। Q is equal to 0. From first law of thermodynamics, we know that Q is equal to delta U plus W. That means when we supply heat to the system, part of it will be used for increasing internal energy and the remaining part will be used for doing work done. Here Q is equal to 0, therefore change in internal energy is equal to minus work done. Now there are two options. First one is when a system expands adiabatically. System expands, that means work is done by the system on the surrounding. Then W is positive. When W is positive, then change in internal energy is negative, means internal energy of the system will decrease. When there is adiabatic compression, gas is compressed, that means volume decreases. This work is done by the environment on the system, and W is negative. When W is negative, delta U is positive, that means internal energy of the system increases. And note that in adiabatic process, temperature and the internal energy both changes. In comment box, write down the adiabatic processes. Give me at least one or the two examples. One example is puncturing of inflated balloon. इस चेंजेस इतना सडन होता है कि सिस्टम और सराउंडिंग के बीच में हीट एक्सचेंज करने के लिए टाइम ही नहीं मिलता। दूसरा होता है बस्टिंग ऑफ टायर। बहुत फास्ट होता है, इतना रैपिड होता है कि जो है इन्वायरमेंट और सिस्टम के बीच में हीट एक्सचेंज करने का टाइम नहीं रहता। लेट्स कैलकुलेट द वर्क डन इन एन एडियाबैटिक प्रोसेस. For an adiabatic process, P V raised to gamma is equal to constant C, where gamma is equal to Cp upon Cv. Cp is the specific heat at constant pressure and Cv is specific heat at constant volume. For monoatomic gas, gamma is equal to 5 by 3. For diatomic, it is 7 by 5, and for polyatomic, it is 4 by 3. Change in internal energy in an adiabatic process, delta U is equal to Cv into delta T. Work done, W is equal to integration from initial volume Vi to final volume Vf, P dV, P into dV. Let this be the equation number 1. Now we can put the value of P from equation 1. This will be equal to integration from Vi to Vf. P is equal to constant divided upon V raised to gamma. Constant divided upon V raised to power gamma is equal to dV. We know that constant is always taken out from integration. So this will be equal to constant integration of Vi to Vf, and we can write V raised to gamma as V raised to minus gamma into dV. Now we have to integrate it. You know that integration of 1 upon x dx is equal to x raised to n plus 1 divided by n plus 1. Use this formula here. It will be equal to constant integration of Vi to Vf. V raised to minus gamma plus 1 divided upon the minus gamma plus. Sorry. Now this integration we have completed, and initial limit Vi to final limit Vf. Now we have to put these limits here. This will be equal to constant times V. At the place of V, we will write Vf minus gamma plus 1 minus lower limit. Lower limit is the Vi minus gamma plus 1 whole divided by minus gamma plus 1. Now we can write it C divided upon 1 minus gamma. We use x raised to minus 1 is equal to 1 upon x. We can write it as 1 upon Vf gamma minus 1 minus 1 upon Vi gamma minus 1. From first equation, we know that PV raised to gamma is equal to constant. Or we can write down for the initial and the final volume Pi Vi की power gamma is equal to the Pf into Vf की power gamma, which is equal to C. Now this will be equal to C. At the place of C, we can write the value in terms of Pi Vi and Pf Vf. Here it is the Vf. Therefore, at place of C, we will write Vf. Pf Vf की पावर गामा डिवाइडेड बाई Vf और गामा minus 1 minus C is multiplied here also. At the place of C, I will write down Pi Vi raised to gamma. Pi Vi raised to gamma divided upon Vi raised to gamma minus 1. Now simplify it. It is equal to 1 upon 1 minus gamma. When this power will go in the numerator, it will be Vf raised to gamma multiplied by Vf. Now sign will change. It will be the minus gamma minus 1. So this will be equal to Vf gamma into Vf minus gamma plus 1. We can write it as Vf gamma into Vf minus gamma into Vf. This is equal to because base is same, power will be added, gamma minus gamma is 0, power of 0 is 0 power of any number is 1, it will be equal to Vf. It will be equal to Pf into the Vf minus Pi into V. Now we know that PV is equal to nRT. You know that PV is equal to nRT. Now we can change PF VF and PI VI in terms of the nRT. nR is constant, n is the number of moles, R is the universal gas constant, T is the only variable, because in adiabatic process temperature changes. So we can write it as work done W is equal to nR, I will take common, divided upon 1 minus gamma nR. This will be equal to Tf minus Ti. Or I can write it as nR gamma minus 1 divided upon Ti minus Tf. This is the work done in the adiabatic process. Now, when W is positive, then W is positive. That means work is done by the system on the surrounding. That means gas expands. When the gas expands, then initial temperature Ti must be greater than the Tf. When work done W is negative, then Ti must be less than Tf. That means system compresses. Work is done on the system. These are all about the adiabatic process. Hope you enjoyed this video. You find it useful and informative. Please like it, share with your friends, and subscribe to my channel. Thank you very much for watching this video.